In this video, we're going to talk about the idea of halogenation, and it is pretty much the addition of what we call X2 across an alkene. Right, so X2 can be in the form of Br2 or Cl2 or I2, etc. So any of those halogens. So simple reaction, I take an alkene, I add Br2, and I get the bromine atoms on either side of the carbon-carbon double bond. Now, the big thing with this is that it shows anti-addition. So the bromine atoms in this case, because we're using bromine, ends up in different planes, right? So it shows anti-addition when we're talking about the stereochemistry, right? So let's look at another example. If we take this molecule and we add Br2, remember we said that we get anti-addition across the double bond, and so essentially we could have one bromine going down and one bromine coming up. And the other can be true, right? I could have the top bromine coming up and the bottom bromine coming down. So this is what we call anti-addition. So for halogenation, we talk about anti-addition, right? It's also true that maybe I could take a cyclohexene, add Cl2, and again, if we predict the products from a halogenation, we may have one chlorine going down and another chlorine coming up. And you'd be sure to get the other enantiomer. Right? Let's do the reaction mechanism. Right? So let's look at the reaction with the cyclopentene that we tried above. Let's look at the mechanism. So in the first step of the reaction, the double bond acts as a nucleophile, takes one of the bromine, and then takes these electrons, put on the bromine in the form of lone pairs, forming a negative charge. Right? So we essentially get bromine minus in solution. Right? Now what happens next is interesting, in that we actually form a bromine, and we have a positive charge on the carbon adjacent to it. Now, because this is unstable, and we know bromine is electronegative, it can actually stabilize a positive charge. It actually attacks the carbon adjacent to it that contains the carbocation, and we get another intermediate. And this, ladies and gentlemen, is what we actually call the bromonium ion. Right? So now the bromine is bonded to both carbons, and it now has a positive charge. Okay? So this is part of the intermediate step. This is what we call the bromonium ion. Now bromine is really stable, so most of the reactions that we're going to do with halogenation are usually bromine, but obviously you can have the chloronium ion as well. Or if you're doing with iodine, you may have the same respective ion. Okay? So in the next step of the reaction, or negatively charged bromine comes in, because now remember, or bromine is pretty much going down. That's what those dashes represent. So the bromine ion that we initially formed in the first step of the reaction now comes in and attacks from above and opens up the carbon chain, and so essentially we get our product to be anti-addition. So the bromine that attack is now up, while we'll still have our the bromine bond still going down, and this is the product of the reaction that we said again, anti-addition. So that is halogenation in a nutshell. Again, if we didn't want to show stereochemistry, again, we may have an alkene like this. We can add I2, and then we essentially get this as the product, again, anti-addition.